Hi, I wanted to just tie up some loose ends and just make sure that everybody is clear on what a focus is, what a directrix is in a parabola. Okay, and so this is a kind of the lesson itself isn't too hard. It's just there's just so many variations of teaching it, and there's just so many variations of each concept, and so I just want to make sure that we're all on the same page. Okay, and so first of all, I want us to focus on the equations. Y minus k is equal to, or yeah, is equal to, we can put 4p in front. 4p is equal to, and then x minus h squared. I also want to focus on 4p, and then the opposite, the x minus h equals y minus k n squared. Okay? Um, there are a few things to note here. One, look at where the squared term is, okay? And if you look at the squared term, notice that it's associated with the x. So if it's associated with the x, we know, and there's no squared term of the y, okay? Since the x is associated with the squared term, the parabola is going to be either pointing up, or pointing down, okay? And in this case right here, since the squared term is associated with the y, okay, the parabola is either going to be pointing to the left or pointing to the right. Now, how do we know which direction it's going to go? Well, look at the 4p right here. If the 4p is positive, it's going to be pointing up. If the 4p in this case is positive, it's going to be pointing to the right. And if the 4p is negative, it's going to be pointing down. And in this situation, it's going to be pointing to the left. Okay. Now the p and each of these variables are really important. Okay. The x and the y obviously are the ordered pair, the coordinate points. The h and k here is the vertex. Okay. So it's that middle part of the parabola. The p tells us this thing called the focus, and we're gonna define that, and the directrix. Okay. The focus is, see here, let's say we have a parabola, is the point that's inside of the parabola, and it's aligned, it's on the same, either horizontally or vertically on the, along with the vertex. Okay. And the directrix is a line that's below in this case. If it's if it's pointing down, it'll be above. If it's pointing to the left, it'll be a vertical line. If it's pointing to the right, it'll also be a vertical line. Okay, so the directrix is always outside the parabola, and the focus is always inside the parabola. I need to emphasize that. Now, what's the purpose of the focus? Well, it's kind of a neat concept. It's this point inside where if you were to put a line anywhere between the focus and any part of the parabola, that distance is going to equal the distance between this point and the directrix. Okay, and this, I didn't draw it very well, but just know that if the focus is equal, the distance between the focus and any point on the parabola is equal to that point and the directrix. Okay, so it's kind of like, it helps you kind of coordinate the parabola a little bit. Okay, all right, so let's check out a few problems here, and yeah, and see like how this is all applied. So let's go with a problem like x squared is equal to 8y. Okay, now this doesn't look anything close to what you had before. But notice first thing is that the squared term is x. Okay, so we're going to be looking at the form y minus k, right? And the 4p's in front is equal to x minus h squared. Okay, because the square terms with the x. Now, looking at this equation right here, is there an h or a k? Okay, you could also look at it this way, where it's x minus 0 squared is equal to 8, and then y minus 0 squared. This and this are the same thing. And notice that both the h and k right here are 0. So since they're both 0, the vertex of this, the h and k is 0, 0. Okay? All right, so if the equation is not really extended, if it's just kind of limited this way, right, then that means that the vertex is 0, 0. Okay, now notice the 4p here. Okay, sorry, you know what, the square shouldn't be here. Notice that the 4p is right here. Okay, there should be no squared term here. Okay, that I made a mistake there. Notice the 4p. The 4p is associated with the 8 right here, correct? Okay, and so then what we do is 4p is equal to 8. We associate those two, make them equal to each other. And so how you determine p is 8, you make them equal to each other, so then p is equal to 4. Okay, now what does that mean? Why do we need p for? What's the purpose of that? Okay, well, first of all, let's graph this parabola. Okay, so here's the y value, here's the y-axis, here's the x-axis. I'm going to change the color. Let's turn it to blue. And the vertex that we found is 0, 0. Okay, if you plug in a number for x, like if we plug this in, you graph this equation. Remember what we did before. Once we found the vertex, we plug in a few numbers for x and y. So let's say, and since this is a square, we want to make this a perfect square. So let's multiply this by 2. If we multiply 8 times 2, that's 16. And then 4 squared is 16, right? So it'll be 4, 2. So it'll be 1, 2, 3, 4, 1, 2. And if we did -4, right? -4, it would also be 2, right? Because -4 squared is positive 16. 16, 8y equals 8y divided by 8, so it's 2. So it'll be -1, 2, 3, 4. So this is going back to algebra 2, where you had to graph parabolas. Okay, and so this is something like this. Again, this part is not important. I don't want to say it's not important, but it's important, but I'm not focusing on that right now. Okay, so just get the general outline of what this parabola is doing. Also note too that it's pointing up because the 8 is positive. Okay, now we have to get the focus. And remember what the focus was. The focus has to be inside the parabola. Now, how are we going to find the focus? That's what the importance of P is. P is 4. Okay, so if P is 4, what we're going to do, and we know that the focus is inside the parabola, you're going to go 4 from the vertex. So 1, 2, 3, 4. So the focus is, in this case, 0, 4. And the directrix is 4 below that, 1, 2, 3, 4. Okay, and keep in mind that the directrix is going to be a line. It's not going to be a point. The point will help us determine where the line is. So once you get the point, remember that the directrix is either a horizontal or a vertical line. So a horizontal and a vertical line. So you're going to draw this out. So through this right here. Okay, and if you remember linear equations, okay, remember if you have horizontal lines, right, then it's y equals, right? It's just one variable, y equals, and wherever the line is, so at -4. Okay, so that's the directrix. Okay, so this is the focus point. This is the directrix. Okay, now keep in mind also that if you have a parabola, let's say this, if you have a parabola pointing to the right, the directrix is going to be a vertical line, and the focus is going to be, remember, this is going to be inside the parabola, and the directrix is going to be a vertical line. And so if it's a vertical line, remember, it's going to be x equals wherever that line is. Okay, let's do another one. Let's do something like, let's say we have x squared plus 8y equals 0. Let's say we have something like that. Okay, well, notice a few things. Notice that the squared term is with the x, and then 8y and this are on the same side of the equal sign. So what we're going to do is we're going to subtract the 8y. We want them on opposing sides here. So it would be x squared is equal to -8y. Okay, again, notice that the squared term is with the x, right? And the -8 is with the y. Also notice that the 8 is negative. Okay, so pretty much what we're gonna have the same equation here, except that what the parabola. So the parabola is 0, 0, and the vertex is 0, 0. It's going to be doing the same thing, except that it's pointing down. Now, how do we know that? Because the 8, right, the number that's next to the single exponent, or the exponent to the first power, is negative. That's why we know it's going to be pointing down. Okay. Keep in mind a few things too, and I want to emphasize this before we go into the next problem, is there are many variations of, again, what different teachers do in this formula. So remember, we got 4p, and then, like, let's say x minus h is equal to, and then y minus k squared, right? And then we have the 4p, and then we have the y minus k equals an x minus h squared. Okay. Teachers have always also taught or mentioned that this is the standard form. This is 1 over 4p y minus k squared. And then this is y minus k is equal to 1 over 4p, and then x minus h squared. Okay, notice that this and this are the same thing, except they just divided the 4p to the other side. Okay, so you're going to see different variations of it. People are also going to mention x minus h is equal to a, and then y minus k squared. They like to use the variable a because of standard form. Okay, so just remember that if you want to get the p, and there's just a single number in front of the squared variable, okay, then you just have to make that equal to 1 over 4p. Okay, and again, we'll deal with that in a little bit. Okay, so, and this is y minus k is equal to a, and then x minus h squared. So people have done this variation as well. And then also keep in mind that x equals a, and then y minus k squared plus h, and y is equal to a, and then x minus h squared plus k. And again, these are all the same thing, okay? It's just, they just did it in different forms. In this case, they added the h to the other side. In this case, they added the k to the other side. And that's the difference between this and this. So kind of just understand the variations of everything, understand like the little nuances, and I think you'll be okay. All right. So let's just say we had a problem. Okay. Let's say we had a problem like y is equal to, I don't know, let's just say like 4, and then x minus 3 squared plus 2. Okay. So this problem isn't that much different from the problems that we had before. And again, don't freak out if you're not familiar with this. You have to try to manipulate it so you can get different forms. But remember that we had it this way, right? Where it was y equals a, and then x minus h squared plus k, right? And remember that a is equal to 4, right? But remember before that we had a was equal to 1 over 4p, correct? Okay, and so what we do is pretty much simply just substitute the 4 for the a. So it'll be 4 is equal to 1 over 4p. And then multiply both sides by 4p, right? And it'll be 16p is equal to 1. And so you divide by 16. And so p is equal to 1/16. What is the vertex? The vertex right here is the h, which is, so the vertex is 3. And since this is a plus and this is a plus, it stays plus, so it's just positive 2. So 3, 2. So how do we get the focus and the directrix? Again, so remember, so here's one line, here's the next, here's the drawing out. So it'll be 3, 1, 2, 3, and then 1, 2. And remember that since the P or the A, the P or the A is positive, right? The parabola is going to be pointing up, right? It should be going like this. And remember the P is 1/16, right? 1 over 16, so you go up 1/16, and this will be the focus. And then right here below is going to be the directrix. That's the point. So you just go something like that. Okay, I'm hoping that kind of helps out a little bit. Let's do a problem, and this will be it. Let's do a problem where the y is squared. Okay, so let's just say we have x minus 3, and then let's just say there's 12 here, is equal to y minus 2 squared, or plus 2 squared. Okay, so again, looking at the equation right here, notice right away that the squared term is with the y. So from there, you should notice, and also the x is not squared. So we know it's going to be a parabola of some sort. Notice that the y is squared, and since the y value is squared, it's either going to be pointing to the right or to the left. And how do we know it's going to be pointing? It depends on this number right here, and since this number is positive, okay, we know it's going to be pointing to the right. Okay. Now, what's the vertex? The h and k is +3 and -2, right? Because if you look at that formula, right, it was 4p x minus h is equal to y minus k squared. And since this sign turned positive, it had to take a negative number to make it positive. So that's why we have 3, -2. Okay, so let's graph this out first. Here and here. And we know that this is 3, 1, 2, 3, and then -2. So here is the vertex. Okay. The next thing is you should graph this parabola. Okay. You could do it in a few ways. I would probably use 0 for y. If you use 0 for, or 0 for x, let's use 0 for x and see what comes. Oh, no, you know what? Let's do a y value. So let's put 0 for y. So it'll be 12, and then x minus 3 is equal to 0 plus 2 squared. So what I'm doing is I'm trying to find, since if y equals 0, I'm trying to find values so that I could graph this parabola. Okay, so this will be 12x minus 36 is equal to, this is 0 plus 2, 0 plus 2 is 2, squared is 4. I'm going to add the 36 and divide the 12, divide the 12 to 40, and so x is equal to 3 and 1/3. So at 0 and then 3 and 1/3, 3 and 1/3 is like right here. That is another point on this parabola. Okay, so now that I went 2 to the left, I'm going to go 2 to the right, and notice if you plug in -4 for if you plug in -4 for this equation for the y, you make y equals -4, you're going to get the same exact x value. And so it's going to be like something like this. So excuse my drawing. I'm going to try to do the best I can, but it's going to be this really open and wide parabola here. Okay. The next thing we're going to try to find is we're going to try to find the focus. And the focus is based on this number, and we have to find what the p is. The p is, again, so this 12 is associated with this 4p. So you make 4p is equal to 12, and you divide it by 4, and so p is equal to 3. So what does that tell us? It tells us the number of spots, the distance from the vertex to the focus. So you go up, so you go to the right 3. So this starts at 3, 4, 5, 6. So the focus is at 6 and -2. And the directrix is going to be 1, 2, 3. We're going to go 3 outside of the parabola. And it's going to be, it happens to be the y-axis here, right? It's going to be this line that's this right here. And what's the equation of this line? Is going to be x is equal to 0. Okay, so the directrix is x equals 0. And the focus is 6, -2. All right, so now what's the axis of symmetry? One last thing, axis of symmetry, AOS. Well, that's the line that goes through the vertex and it cuts the parabola in half. So let me draw this in a different color. Let me paint the line here. So it's going to do something like this, right? Because this is the line that cuts this parabola in half. And so what is the equation of this line? Well, you have to look at, in this case, you have to look at the y value of the vertex, and the y value happens to be -2. So y equals -2 is the vertex, is the axis of symmetry. Okay, I know there was a lot to that, but I think I looked through the PowerPoints, looked through the different steps, and if you have any questions, again, always feel free to ask. Have a good day. Bye.